In today's lesson, we're going to be talking about solving rational inequalities. So what we're looking at here is we're obviously starting to look at rational functions, and rational functions are polynomial divided by polynomial, and now we're looking at solving rational inequalities of these expressions. So the strategy to solving rational inequalities is step one, we're going to have a 0 on the right-hand side. So the first thing you need to do is bring everything to one side of the inequality. Now that I brought everything over to one side of the inequality, we're going to now get a common denominator. Doing so, we get. Now that I've got a common denominator here, what we want to do is you want to get this numerator expressed as a polynomial fully factored. You can see in the bottom here, we already have the bottom already factored, and we're going to use that to discover our inequality and our solutions to our inequality. So we want to do the same here. So I'm going to go ahead and expand this out and simplify. Doing so, we will get, expanding out here, you can see I get 7x plus 4 minus 2x plus 6. I then just simplified and then factored the 5 out. And now you can see what we have here is a polynomial which is factored, another polynomial fully factored. Now the idea here is that solving this rational inequality is equivalent to solving this rational inequality. So therefore, solving this inequality will give us the exact same answer as solving this inequality here. Let's go ahead and look at how we would solve the following. To solve the following inequality, what we want to do is draw ourselves a number line. And then we want to identify the roots of the inequality. So in this case here, we want to take a look at when is the top going to be 0? Well, the top is going to be 0 when x equals -2. So let's write that down. We also want to look at when the bottom is going to be 0. These are the points where the inequality is undefined. Well, that's also going to be at x equals 3 and -4. Plotting these on our number line, we have the following. So you'll notice here I've plotted the 2 points where my rational inequality is undefined. I've also put an open circle on those to remind myself that the function, in this case here, this expression here we're looking at is undefined at -4 and 3. And then we have a root of our rational function at -2. Now what we want to do is you pick a number in this interval, so pick a number larger than 3, and we substitute that into the expression. Doing so, we get, so picking a number greater than 3, like let's say we put 100, if I substitute 100 into here, you're going to notice the top is going to be positive, and the bottom two expressions will also be positive. So therefore, picking a number greater than 3 will yield a positive divided by positive times positive, and the result here is positive. So in this interval, we are positive. Continuing on here, pick a number between -2 and 3. So let's say we pick the number 0. If I sub a 0 into this expression here, you're going to get a positive expression divided by a negative expression and then a positive expression. So the result here will be negative. Continuing on here, pick a number between -4 and -2. So let's say we choose -3. If I sub a -3 into here, we're going to end up getting a negative in the top. The bottom will be a negative number times a positive number, and the result here will be positive. And lastly, with this interval here, we're going to pick a number less than -4. Let's say we put a -10 into here. Putting a -10 into here, we're going to get negative, negative, and negative. 3 negative values results in negative. So putting this together and giving us our answers, we want to know where is the rational function greater than or equal to 0. So we're going to be interested in these two intervals right here. So our answer to this will become open bracket on the -4. And notice here I have to include an open bracket because the rational function is undefined at -4. And again, we put that reminder so we remember that. It goes from -4 until we hit -2. And again, I'm going to put a square bracket on the -2 because at -2, the rational function is 0, and we want to include 0 in our inequality. Union, we're going to go from 3, again, open bracket on that 3 because the rational function is undefined at 3 until we approach infinity. And to remind you guys again, solving this rational inequality here is equivalent to solving the original one which they wanted. So therefore 7 over x minus 3 is greater than or equal to 2 over x plus 4, provided we choose values of x within this interval. Let's look at another problem. In the next example here, same idea. You want to have a 0 on the right-hand side. We already have that, so now I have to fully factor everything. So factor up the top here. You see this factors quite easily into t minus 4 times t plus 3 over t minus 1, and that's less than 0. Draw yourself a number line, and you want to identify the roots of the rational function. Roots of the rational function occur when the top is 0. The top is going to be 0 at 4 and -3. So we've got -3 and 4, and the bottom is going to be 0 when t is 1. So you'll notice here again, I've included an open circle on the 1 to remind myself that 1 is undefined here. And again, what we want to do is pick a number in this interval here first. So pick a number greater than 4. Let's say we put a 10 into here. If I put a 10 into here, we're going to have a positive times a positive times a positive, and the product of 3 positive expressions results in a positive value. So everything in this interval is positive. Now pick a number between 1 and 4. Let's say we pick a 2. If I choose a 2 here, this is going to be negative, positive, and the result is going to be negative. And then pick a number between negative 3 and 1. Let's say we pick a 0. This is negative, this is positive, this is negative, and the result here will be positive. And lastly, pick a number less than minus 3, in which case we get negative, 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 and the result is negative. So putting this all together here, you want to see when is this expression less than 0? That's going to be between 1 and 4. So the answer to this question will be the interval open bracket on the 1, because we can't include the 1 because it's undefined. And then on the 4, we're also going to put open bracket. But the reason we put open bracket here is because we do not have strict equality at the 0. So we want to find an expression that's strictly less than 0. So therefore, if I include the 4, we'll be at 0. So I have open bracket on the 4 and open bracket on the 1 because it is undefined at 1. Let's take a look at another example. In the next example here, same idea. We want to bring everything to one side. Let's do that first. Bringing everything to one side, we now have our 0 on the right-hand side. Let's go ahead and get a common denominator here. Doing so, we get. Now that we've got a common denominator here, I want to expand out the top and simplify, hoping to fully factor our polynomial. Let's go ahead and do that. So taking a look here, I've now expanded everything out. I went ahead and simplified. I got 14x plus 14. Factor out the 14. Now we have a fully factored rational function. You got the top fully factored, the bottom fully factored, and we can go ahead and solve this. And again, to remind you, solving this inequality here is equivalent to solving our original question. So solving this is much easier. We're going to go ahead and do that. In this situation here, again, we want to identify the roots and the points where the rational function is undefined and plot that. So we have undefined points at -6 and 4, and let's go ahead and put open circles on those to remind us that it's undefined there. And then we have a root of the rational function at -1. So same idea here, pick a number greater than 4. So let's say we pick 100. This is going to be positive, this will be positive, and this will be positive. The result is a positive number. So therefore, I know on this interval, the rational function is increasing. Pick a number between -1 and 4. Let's say 0. Put a 0 into here. We got positive, negative, positive, and the result here will be negative. And then pick a number between -6 and -1. Let's say -3. This will be negative, negative, and positive, and the result here will be positive. And then lastly, pick a number less than -6. Let's say -10. We're going to have a negative number, a negative number, and a negative number, and the product will be. So our interest here is whenever the rational function is greater than or equal to 0. So that's going to be where we have a positive values here. So it's going to be here, here, and those two values here. So solving this here, again, notice that we have strict equality. So notice we're including the 0 here. So the answer to this is going to go from open bracket on the -6, because it's undefined there, until we hit the -1 square bracket, because again, we want the situations where our rational function is 0, union, and here we're going to have to go from 4. Notice I have to put open bracket on the 4, because we are undefined there, and then going all the way to infinity, and obviously open bracket on infinity, because you don't include equality on infinity signs, as infinity is not a number, just something that number you're approaching. So in this situation here, the solution to this rational inequality, when is this expression greater than or equal to 0, is going to be these values here. Let's take a look at another example. In our last example here, same idea. We're going to bring everything to one side and get a common denominator. Let's go ahead and do that. So bringing everything to one side here, we go ahead and get a common denominator. As you can see here, I go ahead and factor the top. We do difference of squares. I also factor 3 out of 6x minus 9, and now we have a fully factored rational function. And I want to know when is this less than or equal to 0. So let's go ahead and draw ourselves a number line. On this number line here, we want to identify the points where the function is undefined. That's going to be when the bottom is 0. The bottom is 0 at 0 and 3/2. So let's mark those off. And again, I'll put an open circle on those to remind us that it is undefined there. The other values here are at -1 and 1. So at this point here, we want to know when is this less than or equal to 0. So same idea here. Pick a number in each interval and see whether it is positive or negative when substituted in to this expression. So pick a value greater than 3/2. Let's say 10. In this case here, we're going to have positive, 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 positive. So the product here is positive. Next, pick a number between 1 and 1.5. Pick a number between 1 and 1.5. Let's say 1 1/4. If we substitute 1 1/4 into here, we're going to get positive, positive, positive. And this expression here will be 2 times 1.25, which would be 2.5. We actually get a negative value here. So this will be, like we said, positive, 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 and negative. So the resulting value here will be negative. Continuing on here, pick a number between 0 and 1. Pick a number between 0 and 1 here. Let's say 1/2. We're going to end up getting negative, positive, positive, negative, and the result will be positive. And now pick a number between -1 and 0. Let's say -1/2. If we put in -1/2 here, we're going to have a negative value, positive value, negative value, negative value. And the result here will be negative. And lastly, pick a number less than -1. Let's say -10. We're going to have negative, 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 and negative. 4 negatives is positive. So we're interested in intervals where the rational inequality is less than or equal to 0. So we're interested in this interval and this interval here. So our answer here will be square bracket on the -1, because that'll be a root until we hit 0, and then open bracket because the function is undefined at 0, union that up, and then square bracket again on the 1, going up to 3/2, and then open bracket on the 3/2 as well. And this would be our answer in this situation here. All right, that concludes today's lesson on solving rational inequalities. Thank you.